All right, welcome to Corvid Coder. Today we're going to go back to our game utilities library, Nuthatch. All right, now that I tested the stream works, I can turn that off. Okay, so I'm just going to go straight into Nuthatch and the art for it. So what we're going to do today is we're going to work for about an hour, let's say until about 2 to 10, I guess. And that's Mountain Central Time, or Mountain Time. And today we're going to work on graphics, I'm pretty sure. So I'm going to spend a lot of time on graphics, so this is just 1 hour on it. So we're not going to get too far, I assume. Like maybe we'll load up a GL context. But we're going to talk about that a little bit first. If you haven't tuned into the stream before, the stream is Corvid Coder. We just kind of build things from scratch using JavaScript primarily. I do want to do some Rust projects in the future though, so I'm kind of thinking about what a good project for that would be. And we just kind of make stuff. I try to talk about it as I'm doing it. It's very akin to Handmade Hero or Handmade Quake if you've seen those, or possibly even the Coding Train by Schiffman. I have a Patreon page has some links and some information about it. Okay, so let's get going. So, oh yeah, all the code lives in GitHub too. So there's a GitHub Corvid Coder where this all is. So you can see I have Nuthatch and UI Design Challenge in here. If you download the Mischief program here, you can actually view this art file that I have. All right. So we're on day 3. We're on day 4. Okay, I need to fix that. Day 4. Okay. So let's go down to there. Let's create my brush back. It's a big brush. It's not a brush at all, it's an eraser. Okay, so day 4. And I'm going to create a bookmark here so we can get back to it really easy if we want. Oops, not mean to do that. Day 4. Apparently this is not a keyboard-friendly application. Okay, so things we want to focus on today are the graphics. So this is a big undertaking. So probably today we're just going to do the context. There's a lot of kind of boilerplate work you have to do with graphics, contexts, depending on which one you do. So I kind of want to do some of the work around that. So the contexts that are provided on the web are Canvas, 2D, WebGL, and WebGL 2. So I am planning on using WebGL 2. So it's going to be OpenGL for the web, which if anyone who has done that knows how much boilerplate goes into that. So I'm just going to go look up real quick who can use WebGL version 2. I'm pretty sure it's just Firefox and Chrome right now. That search didn't work. WebGL 2. So it's just Chrome and Firefox, and then Opera. Opera is just it uses the Chrome layout in JavaScript engine now. It just has its own UI and services around it. So it's decent support. I'd like to see it in Edge. I wonder if I can find, oh, it's right here. And then Safari has it behind a flag. Or it's in preview or something. And then let's see. Edge said that they're considering it. It has a lot of votes. This is wrong. Or out of date. That's always going to be true. Medium, okay. Wonder if I can like see the row. Okay, I'm getting kind of distracted here. So let's just focus on getting the context, and then we'll decide where to go from there. So I'm going to go ahead and open up Atom here. Here's Atom. I like Atom over here, actually. We'll get the... We're going to keep this in the background here. I'll just put it here. It's not as important. And then, let's see what all happened here. Just undo all of this. Okay, so there's the graphics here. So the first to-do I'm going to add onto here is we need a context. Obviously, there's going to be a ton more onto here, such as like rectangles, images, rotations, all that stuff. But for now, I'll just do the context. So it's been 2 days. Let's see if I can remember how to even start this project. So we're creating a new folder. We call it graphics. Before I commit to graphics, I actually want to think about that for 1 second. I'm tempted just to call it WebGL too. Let's assume that I'm going to create one graphics context, and it's going to be just graphics. I'm going to use WebGL 2 for it. I'm not going to support other backends, let's say. If that time comes, that time will come. So inside of there, we need a, let's just copy all this. Okay, so we have a TS config that can probably stay. We have a README, graphics. We have a package.json, graphics, a WebGL2 graphics utility. I can probably stay. I will need to open up tests. I don't want to pull in keyboard, I want to pull in graphics. Oops. And it's going to be called graphics equals. So I need to think about this for a second. And then all of this, I'm just going to delete. Okay. So let's do test on the bottom, code on the top. Oh, now I need to figure out how to run this test. So I need to probably, I need to go into the folder first though. It's going to be Corvid Nuthatch. Okay, so I think I set up a dev. I don't want to do that necessarily. I'm going to run npx learn bootstrap. That should install the packages for this. There aren't really any special ones needed. And then for this package.json, I don't know. What is the keyword package.json? Why is this so? What happened to my package.json? All of these packages. Lerna, what are you doing? Why are you messing everything up, Lerna? Like, this literally didn't happen last time. I wonder if it's going to bring them back when it's done with this. Oh, I did bring them back. That was weird. Okay. So inside of graphics, I just want to run npm test. Oh, no. Cancel. I want to do that inside of graphics. npm test. And then I also want to run npm run dev or derv. Okay. So now it is both compiling my graphics. Okay. So yeah. So this is all good. So I'm ready to start working on this. So yeah, it's true. There's the thing Nothing to do yet. So I'm just going to ignore this for now and just work on this. How do I want to create a context? Do I want to... I guess just calling new graphics should create a context. And graphics, I should be able to say something like graphics dot. For now, we'll just console log graphics because I don't know what I want to work on first. So it's going to be export default class graphics. It's going to have a constructor. It's going to do something in there. Okay, so now we have an empty class. Let's go to MDN and look at WebGL 2. Oh, so do we take a canvas or do we provide a canvas? I think we're going to provide a canvas, but then we need a target element we're putting the canvas into. I want to think about that for a little bit here. So I have this, do I want to create, I think we're going to do target element. So we're going to take in a, if I want to put it into body, do I want to take a DOM element or I don't want to take a selector. I probably want to take an actual DOM element. This document.body would work. And this would be a target, which is a DOM element. Help me out here, TypeScript, come on. Didn't like DOM element. TypeScript DOM element. HTML element? Did I lose my TypeScript stuff? No, it's right here. I'm not convinced this is actually working. Oh, maybe if I just do something random. Huh. Yeah, I'm really not convinced that TypeScript is actually working. Okay, so we'll just go on without it for now. So I guess it like that because it would cannot write file because it would overwrite the file. That's kind of what I want you to do though. Anyways. I'm going to search that real quick. TypeScript could not write file because it would overwrite input file. Oh, no, that's not an input file. I do need to exclude that if that thinks it's an input file. I also need to exclude index.js. I also need to exclude index. Does that help? Target is declared but never used. Okay, so now we're actually getting some more useful stuff here. Can I really not call this a DOM element? I just cannot call it a DOM element. No, I thought maybe that would give me TypeScript stuff down here. HTML element. So target equals target. I think there's a shorthand for doing this, but oh wait, I don't actually need to store this anymore. I don't care about it. This.target.append child new document create element. Wait. Const canvas equals new canvas. Can I do that? I just want to create a canvas element. I can do that through document.create element because can I also just do new. Let me just try it out. Okay, so I'm going to do document.create element canvas. And I'm going to say this.context equals canvas.getContext WebGL2. Cannot read property append child because I can actually append it. Oh, because it's just target. Okay, did it actually? Oh, there is a canvas there. Nice. And I have a context now. I would like for TypeScript to not be so willy-nilly about this, though. Let's see if that works. Can I find name WebGL rendering context? I want a TypeScript class for this. WebGL2 rendering context. So like a definitely typed or something I need. TypeScript type. Property context does not exist on graphics. Okay. Experimental WebGL rendering context. Canvas rendering context 2E WebGL. So I need something special. There needs to be a 2 in here. I'm almost positive. I wonder if it's because Edge doesn't support it. They're not putting it into TypeScript. It doesn't support it yet. Everything we're doing here are web standards, so eventually it will be supported, just not yet in all browsers. Definitely typed WebGL2. So there is a WebGL2 definitely typed thing. It's relatively new. Let's go take a look at what's all in there. WebGL2 rendering. Look at that. Look at that beauty. So I want this as a part of it. Okay, so I think the way I do that, it's been a while. It's npm install types WebGL2. Let's see what that gets us. And look at all the stuff it gives us. All of the stuff I want from TypeScript. Cool. So now if I start running TypeScript again, it should be okay with my WebGL2 rendering context. Oh, God. Type WebGL2 rendering context or null is not assignable to type WebGL2 rendering context. Type null is, okay, so it's possible that this is returning null. I have no idea if this is a TypeScript thing. It was okay with that. About that. If I go back to null. I didn't like that. Okay. I'm going to look that up real quick. TypeScript exclamation point. So what does it do? So it asserts that it's not null. Okay, so I guess I can't actually do that. So we're going to say const context equals, I can't assert it's not null, if not context. I'm going to throw an error. Throw new error. Browser, this browser, or was failed to retrieve. Let's see if there's any better words I can use around here from get context. Method returns a drawing context. So I guess retrieve. You just use get. Failed to get WebGL2. I'm going to replace all of these with backticks. So we can put just quotes here. From browser. So then TypeScript now knows that if I'm at this point, context exists, because this, you can't get past this without null being caught in here. So TypeScript should be okay with this. It is okay with it. It's able to do a stack analysis branching here where it's like, hey, this is either WebGL2 or null. Here it's saying only null will come into here, or something like null. Here you cannot be null anymore. So that's one feature about TypeScript I think is pretty dang cool. Did I kill the test? Oh, the test died. I wonder why. Error event? Okay. Okay, so it's in there. We got a context. Nice. So I guess we can keep going from here. So we have a canvas, and we, oh, so context has a notion of a canvas, okay. Has its height and width. So we have a graphics object, we have our WebGL2 context. From here it's gonna get, this is the boilerplate part. Let's just see if we can find an example one, because this is the context. I guess it should be called GL. It's kind of the de facto. Wait, how do I do enter? Okay, then change all that stuff. So, oh, tutorial, okay. No. No. Using ES3. Okay, I guess the setup part might be the same. Okay, so the canvas comes in, we set the GL, we do a thing here. Okay, let's try it. So we're going to do a function called clear. And it's going to take in a color, create color interface. For now, we're just going to say this.gl.clear color equals black, and this.clear. So now, if we look at this, if I add into here graphics.clear and call it, it fails. Execute clear. One argument required, but only 0 present. So I think I have to pass in like a true or something. Oh, no. I need a... See, this is where TypeScript would have been useful here. that would have been really useful here. Let's just go docs.gl. We want clear. We want it for ES3. WebGL 2 is the same as ES3. I guess that's worth taking a break for. So, world of WebGL is pretty complex. It has a long history before WebGL ever came around. So, OpenGL is a standard that was put forward by the Kronos group, and still is put forward by the Kronos group. People were doing graphics for a while, like I don't know, like Doom days, I guess, and they're like, hey, it'd be useful if there was one library for how to do all this graphics. So the Kronos group was devised the plan for, hey, we're going to standardize a library for doing graphics. So OpenGL, GL stands for graphics library. Let's just look at like 1.0, and I believe it's through 3.0. I'm going to check real quick. Yeah, it looks like it is through 3. Well, I don't know. Compute. So that came around 4. So maybe it was 1 through 2. What kind of shader stuff do I have? There's a VBO, vertex, buffer. Are these really that new? So don't quote me on this, but it's 1 through something. I'm going to put a question mark on this number because I'm not really so sure. And these were fixed function pipeline. So these things were, they were like, you could do GL begin, and then you can do all your triangles and stuff, your lighting, and then you call GL end, and that would print out a pretty thing to your screen. And this was okay for kind of games, like they all kind of look the same. Oh shoot. So everything that you did OpenGL-wise would have to happen in between your GL begin, your GL end. So wasn't the most flexible thing. Didn't give you too much control. It's kind of like running a program inside of your program where it was doing something and it was keeping state here, like you were managing state, and at the end it would do your graphics for you. But now we're on this thing. Everything is a shader now. So everything is shaders now. And OpenGL uses GLSL, the graphics library shader language. Actually, I don't know if it stands for graphics library. I'm going to look it up. Okay, so it doesn't actually, they never say graphics library shader language. They just say GSL slang. It's shader language, OpenGL shader language. So you don't have this thing here where you say like, hey, I want lights, and hey, I want triangles, and other things like that. Now it's like, I have some vertexes, and I'm going to put it into a program, and this is going to be your vertex shader. So shader is just a bad name for these. As far as I can tell, these are bad names. And so your vertexes on your screen might look like this, right? And your vertex shader says like, hey, these are triangles. Here's a triangle. Great. Or it could do something even like where it translates it all. It's like, hey, my vertex shader actually just moves everything. And now my triangle's over here. That's cool too. So after it does that, you can input whatever you want. There can be other things coming into here. You can output whatever you want. But let's just assume that we just outputted a GL position. So the position of each one of these. And that goes into your next one. That's your pixel shader. And this is more what we'd think a shader would be. So now it's going to take a grid, and you're going to write a program that says what to do with each one of these grids. So one thing you might do is giving a triangle that looks like this. You're going to say, like, this should be filled, this should be filled, this should be filled, this should be filled, this should be filled. Like there's my triangle on this grid. And that's what my pixel shader did. Maybe we can make it a little bit more like a triangle here. But that's what your pixel shader does. And then it outputs a frame buffer. So this is your standard kind of new shader pipeline. You have to write this program. Well, sorry. You have to write that shader and you have to write this program. And the combination of these is a program. So you write the two shaders. The vertex shader and pixel shader combined makes a program inside of OpenGL or WebGL. You have to write this vertex, you have to pass it to your shader, you have to write this pixel shader, you have to pass things to it, and then you have to pass out the data from here. This is your frag color. This is your GL positions, and these are generally your vertexes. So why'd they do this? This looks horribly complicated compared to this, where it's just like GL begin, and you're like triangle, 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 colors, colors, lighting, end. This has maximum flexibility. And maximum is maybe a little bit generous to use here. I don't know if it's flexibility. Oh my gosh. Flexibility. I want there to be an A there, but I'm pretty sure it's an I. You can write this program to do anything you want. You can have it do squares instead. You can't actually do that in WebGL, but in later version of OpenGL you can. You could have the pixel shader do entirely arbitrary things. You could have it like turn the triangle into 3 points that rotate. You could, I mean, it's literally anything you want. You can make them shiny. You can make them embossed. You could, like, those are a lot of like physical material characteristics that you can put to it, but that's not what you're limited to. You don't even have to be doing graphics. OpenGL, the latest one, lets you do other things that are more akin to like data processing like we think about. I mean, this is literally data processing. It's just specifics to graphics, where it takes in triangles and then fills them in. But there's no reason why your triangles have to be things that are going to be shown to a user on a screen. It could be like locations, like maybe the X, Y, and Z is like the X and Y coordinates on a map, and the Z you use as like a weight for that edge or whatever, or that vertex. Like maybe you're trying to navigate something. And then your pixel shader can go over each one of those and then do some compute. And then your frame buffer comes out and you have to look at it, and X, Y, and Z is not necessarily a color. It's like the result of whatever you computed through your pipeline. So you can do massively parallel computations using this, but it has to fit into, for WebGL at least, has to fit into kind of a more graphics-centric pipeline of vertex to pixel. In the latest OpenGL, you can just do compute shaders and kind of do whatever the hell you want, just like a CPU that's massively parallel. So this is how WebGL works. This is how WebGL 2 works. WebGL 2, though, so in WebGL 1, so one of the things that was different about it was WebGL 1 had a lot of things were extensions, so it was optional if browsers wanted to implement them, or if, pretty much it was optional if browsers wanted to implement them. Where now with WebGL 2, it's kind of a lot of the WebGL stuff, but they took a lot of the extensions and then they mandated them. So they're not optional anymore. In order to have a WebGL 2 compliant browser, it has to implement a lot of the things that were extensions in WebGL 1. Another thing that they changed was they removed a lot of features or a lot of API endpoints. I'm not going to say features, but a lot of the things that you could do in WebGL 1 were kind of relics of the fixed pipeline, the fixed function pipeline. So they removed those. So like everything has to go through this pipeline. There aren't really that many shortcuts, like clear is still there and stuff like that. So in order for us to get to a point where we can draw a triangle, we need to create a vertex buffer array. We need to create a vertex shader. It doesn't have to be complicated. We need to create a pixel shader. Once again, it doesn't have to be complicated. And then we need to render it to our canvas. I believe this part is automatic. We'll have to look again. It's been a while. I believe we don't actually have to do this. This part just happens for us. We compile it into a program, and then we have to run it. All that needs to happen to get a triangle on the screen. In order to write these, we have to write in a different language than JavaScript. It is going to be the GLSL language. I believe version 5 is what WebGL 2 uses. Well, we'll find out. So I guess let's go figure out why clear didn't work. So, actually, there's more to talk about. So, OpenGL. This has like, version 2, version 3, version 4, version 5. There's Vulkan. I don't know too much about it, so I don't know if there's like version 1 or not. And then there's WebGL. And then there's OpenGL ES. And there was version 2 and 3. I'm not familiar with version 1, so I'm going to leave that out. I'll write that in red with question mark. WebGL, there is a version 1 and a version 2. Vulkan, I have no idea. So I believe it is version 4. I'll get out a different color here. Version 4 of this, I believe, corresponds to, well, so roughly I believe version 2 is a reduced set of version 3. So I believe this is a reduced set of this. And then version 1 is a reduced set of that, or not necessarily reduced, I think it might be reduced, of that. So, and then version 4 goes to WebGL's version 3, which I believe is a reduced set. These arrows aren't so, these aren't hard ties to this. These were kind of in parallel to these. It wasn't like this to that, this to that. However, these ones were much more succinct. So OpenGL ES version 3 was very much what version 2 of WebGL was based off of, and then vice versa. So whenever we're going to look up versions for, because there's not too much on WebGL version 2 yet on the web, or there aren't many good tutorials from what I can tell or anything like that. MDN is like the best one, and it's just like a manual. So whenever we're looking up stuff, I'm going to look at OpenGL ES version 3, and then we just have to figure out how to write that in a WebGL way. It's usually pretty similar. Almost all of the examples I have on mine are like Android or C or C++, and we're going to write it in JavaScript. So you'd be surprised how straightforward that is. But okay, so that's why I'm about to go into OpenGL ES version 3. So I'm about to look at the clear for this, because that corresponds to the WebGL version 2 that we're about to use. So OpenGL is not for the faint of heart. I'll just say that. So let's go back to the browser. So I was about to look up clear for ES3. So geoclear, clear buffers to preset values. So I want to clear, a bit field mask. It's actually not what I wanted. I need to clear buffer, clear color, clear depth, clear index, clear stencil. Actually, that is what I want. I need to send in like the buffer that I want to clear though, I feel like. So let's check out clear color. So it takes in the colors, let's get it clear. Okay, I need to look at this again. Syntax error. Let's never finish this. Is just this good? So that's okay. It's this clear that's getting it wrong. So failed to execute clear at WebGL. One argument required, but only 0 present. Let's just try passing in true. Invalid range. Okay. Invalid mask. Let's try a 0. So it was okay with that, but it didn't do anything. 1. It was okay. No, it wasn't. Invalid value. Clear. Invalid mask. So 0 is a valid mask. I just don't really know what it's asking for. So I'm going to go over to our WebGL 2 reference. Because, oh, here we go, color bit. I would like to go to my WebGL 2 reference anyways, though. WebGL constants, okay. So if I look at clear, clearing buffers. Constants passing to clear the buffers. I can clear the depth buffer, I can clear the stencil, and I can clear the color buffer bit. So in order to do that, I do this.gl.color buffer bit. And can I read property GL? Let's try that again. Oh, I'm writing this in the wrong spot. Color. This is where it would be nice if TypeScript was kind of stepping in to help, because it would have told me that sort of stuff. Okay, so clear is working. Next thing we want to do is we want to get a triangle on the screen, which sounds easy, but once we get that done, then we can do a whole lot more. So let's go back to our tutorial. And like, I feel like this isn't going to cover what I need it to be. Adding 2D content. Oh, I saw using shaders, so I see shaders here. Let's see what they're drawing. A square. Okay. And how are they doing it? They're clearing. They're doing a perspective, they translate, creating a matrix, bind buffer. So it looks like they're doing it kind of the new way here. Use program. Or was that program created? Up here. Oh, it wasn't created, it was info. I feel like I don't need this. Are they using a library? Something looks off to me. So this looks fine. This is a vertex shader. It has a main function. They have 2 uniforms. That looks good. They have a color. They're setting everything to white. It's fine. Creating their shader program, which, okay, so this is what I was expecting it to look like. It loads a shader, attaches them, links them. Does some error checking, okay. And then it loads the shader. So this is how you call it, okay. This is what's throwing me off. What is this? After we've created a shader program, we need to look up locations of WebGL assigned to our inputs. In this case, we have 1 attribute and 2 uniforms. I guess this is just like a custom format that you can create. Attributes receive values from buffers. Each iteration of the vertex shader receives the next value from the buffer assigned to that attribute. Uniforms are similar to JavaScript global variables. They stay the same. Okay, so since the attribute, I already talked about this. So what are we using program info for in here? Nothing in here. We're just creating buffers. Creating a buffer. And then we're going to put this stuff into the buffer. And return it. So we're using it down here. So program info. Okay, so it's just the format they created. Okay, so they just use it throughout their program. That's fine. So this is a good starting point for us. So here's the thing I don't like. Well, we'll see what happens first, but let's go ahead and create our two shaders. So const vertex shader source equals, like, we don't get any syntax highlighting, linting, or anything. I get nothing. So ideally, not ideally, because we can't pull it out. I can't import this. We'll deal with this for now. But I would like to get linting and stuff going eventually. I don't want anything complicated yet. So we're just going to say, oh, this actually changed between GL versions. So varying vertex position. Semicolons are not optional in this language. This is a vec4. So this is saying that we expect vec4s to be passed into our vertex shader through a buffer. And then we're going to take this buffer, and whatever is passed in the GL position is going to come out in our fragment shader. So I call it a pixel shader, fragment shader. That's a better name for it, actually. We're going to have, so in here, it's actually, we don't care about the vertex positions. We're going to just set all of the frag colors equal to a single thing. So you can use vec4 for colors, you can use like vec4 for positions. We're going to do, let's just do red. We have to do dots because they have to be floats. Oh, I don't have to, but they have to be the same throughout. So we're going to set ours to red. Okay. So now we need to initialize the shaders. So let's go ahead and create our function. Let's do a fat arrow. Initialize shader program. Takes in a GL context. Takes in a vertex source. And it takes in a fragment shader source. I actually want to use like the extended names. Okay. And I said fat arrow, and then I just failed to create a fat arrow. Okay. Oh boy, it doesn't like stuff. So it says vertex shader source is declared but never used. Oh yeah, that's fine. These are all just warnings. These are errors. Okay, whatever. Let's just keep going for now. Looks like a lot of it is just warning me I'm not using the stuff. So I'm going to create a vertex shader, and it's going to look like load shader, so I have to write that later, I'm assuming. And then we're going to pass in the vertex shader source. We're going to do something similar in here, but we'll replace the word vertex with fragment. Oh, and this one. Oh, in all caps. And then we're going to create a program now. Const shader program equals gl.create program. So this creates a shell of a program. So it pretty much tells our graphics card, it says, hey, create a pointer to a program on the graphics card. We have nothing to put there yet, but have a pointer to it, and we can refer to it later. So then now we're going to put stuff in the program. So gl.attach shader program. We're going to, so now the vertex shader is attached to it. Now we're going to attach the fragment shader to it. And then we're going to more or less compile the program. So now we're going to test if it actually worked. If not, gl.get program parameter shader program link status. Throw new error. I'm not going to do these alerts. Unable to initialize the shader program, and then I guess there's some reasoning for it. gl.get program info log. Shader program. Okay. Do I put that on a new line too? I'll put that on a new line. Okay. So if it doesn't, go ahead and return the new shader program. I'm going to create a function. It's going to be a WebGL to rendering context. This is going to be a string. This is going to be a string. And this is going to return a WebGL shader program. Really don't know. I want the type, well, it should be in here. So we gotta create program, or what was it? Initialize program? Create program. It was create program. Where's all my shader stuff? Oh, I know why. So this is all the stuff that is specific to WebGL 2. No, it doesn't. Oh, it's an extension of WebGL 1. The WebGL 2 rendering context interface implements all members of WebGL 1 interface. Some methods of the WebGL 1 context can accept additional values when using WebGL 2. You'll find this, okay, so I need to go over to WebGL 1 to find create program. Yeah, that's annoying. So returns a WebGL program. So it's a WebGL program. Let's see, it's compiling about line 15. Identifier expected. At column 10. Oh, I need to name it. Net shader program. Okay, so cool. So it says vertex shader source is a clever never used, cannot find name load shader. Oh, yeah. Have not written that yet. Type WebGL program, null is not assignable to type WebGL program. Okay, so I need one more additional check in here. I actually don't really want that as a template. If not shader program, then throw new error. Failed to initialize shader or program WebGL program. Cool, okay. So now we just need a WebGL program. Or load shader. So let's go look at what that might look like. Did I? Oh, okay, it's right there. It's a WebGL2 rendering context. Type, oh boy, and then a source, which is a string. Let's go find out what type that is. So that's a WebGL2 types, TypeScript. How did I get there before? Definitely typed. There we go. So I want something like vertex inside of the definition. Not that one, not that one, not that one. Nope, nope, nope. Keep going, keep going, keep going. Keep going. Keep going. Oh, vertex shader. So I guess I literally just make a union type here. It's going to be can I do that? I guess so. Okay. So then it returns a WebGL shader. Actually, no, yeah, what it returns. And then we actually need to write the function part of it. Okay. Okay. So we keep that open. Keep that open. Keep these two open. I wish I could have both of these on one page, but I guess that's what docs.gl technically is. So load shader. So what does it do? It says const shader equals gl.create shader. Whatever type we passed in, either fragment or vertex. And then we say shader source. We're going to say that the source of it so we're going to say take the text, put it into the shader. So once again, this is just a pointer onto the GPU. We're saying we're going to be creating a shader. It's going to be of this type. Find a place on the GPU for it. So the GPU goes and gets some memory space for it. And that's what the shader is. It's a pointer to that. So now we're saying like, hey, that pointer, put the source code in there. Now we're saying, hey, remember that source code I put in there? Compile it. Tell me what errors I have. And then here's a block that'll tell me the compilation errors I have, and we'll test that out real quick. So if not gl.getShader parameter, gl.compile status, throw new error. We're going to do not fat arrows, but template literals here. Going to put this all into a template literal. And there we go. Oh, I need to delete. Oh, I can't change the order of these. So it needs to be message equals this thing. And then we put message into here. So the reason why I need to do it in this order by pulling this out is if I delete this shader, I can't get the shader info log, I'm assuming. I guess maybe I could. But then if I do this first and I throw, then I'll never get to the next line. I don't need to return it all because I'm throwing. So we're going to get the message, delete it, and then tell us about the message. And then if that's all good, then we're going to return the shader. So I can almost guarantee it's going to complain about shader now. Yes. So we need to say if no shader, throw new error, failed to create WebGL shader. Right up here. Failed to create WebGL2 program. Okay. So what do we got? Okay, but we're not calling this yet because we're not doing anything with it. Phew. So I skipped all of this stuff. We do need to do this though. Just ignore that for now. Let's just call one called test. So we're going to call test now. So far, you know, it doesn't do anything, so that's fine. Probably get rid of this. Okay. And so we're going to create a program inside of test. So const program equals shader program. It needs to take in the context and the two sources. Vertex shader source, fragment shader source. So far, so good. So now we have the program. Now we need to get the attribute. So const position. What do I call it? Vertex position. gl.get this.gl. Get attribute. Location. We're going to take it out of the program. And it's called vertex position. So they put an A in front of it because that's what attribute stands for. They put a U in front of it because that's what uniform stands for. Okay. So I don't need either of these yet. I skipped those. So now we need to initialize our buffer. So const position buffer. This is once again saying like, hey, graphics card, please create a place for my buffer to sit. And we're going to put stuff in it. So bind buffer. So we're like, hey, remember that buffer I created on the graphics card? It's now going to be assigned to our array buffer in the shader. So it's going to go into our vertex shader. So now we need to create some positions. I'm just going to do, how'd they get this to turn into a square? Oh, they use triangle strip. Okay. So we're just going to do one triangle for now. I don't think I want to use triangle strip. So we're going to go from the, I believe the upper right to the upper left. I feel like we're going backwards. I want to go to the bottom left, or clockwise? I think I want to go clockwise. So I'm going to go to the bottom left. That'd be -1. Oh, this is like, okay, I was just interpreting it wrong. It's fine. And then I want to go to the top left. So that'd be -1.0 and -1.0. So this is the upper right, bottom left, top left. And if we looked at that a little bit closer, so we have this, and I believe OpenGL contexts usually go from 1 to -1. This is where I might get it wrong. So 1 to -1, it might be flipped on the y-axis. So we were doing 1, 1, -1, -1, and -1, 1. And this order is important. If something is back-facing or forward-facing matters. So 1, 2, 3. This should have gone through here, but whatever. Okay, so we'll find out if that's what I got or not. So now we need to say, hey, I got this data in JavaScript. I need to send it from the CPU memory over to the GPU memory. And that's what buffer data is going to do for us. And we're going to say, hey, we're going to put it in the buffer, which remember is bound to the buffer we created. So we created a buffer and we bound it to array buffer, and now we're putting stuff into that. So we're technically putting it into this buffer we created here. It's going to be a float 32 array. WebGL does not care about, well, so JavaScript doesn't care about numbers. JavaScript only has floats. So we're just going to put them in as floats. WebGL and other languages very much care about what the type of numbers are, or type of data type, really. And then this is telling the graphics card, it's kind of giving it hints about the type of data we're passing. So there's other, static is the only one I know of, because that's one you're supposed to use if you can. But saying, this information I'm giving to you is not going to change. So you can do optimizations based on that fact. So I'm going to give it these things, and it's never going to change, so it can just assume that. So my understanding is that most graphics cards optimize to this, when some try to and then actually make it slower. But I didn't create a function, so we don't need to return. We just have the position buffer. So now to render the scene. So you start out by clearing. You enable some, we don't need a depth test. We're not doing anything depth-wise. We don't need to clear the stuff because we already did. We don't have a matrix, so we're going to skip all that. We're not going to translate it. Let's see, what is this for? So we got num components type normalize and we're telling the graphics card how to read from our buffer array. So when he says num components, he's saying only read these 2 at a time. So this is the x position, this is the y position. This is 2. Don't read 4 of them, because that would be 2 of our points of the triangle. We only want to read 1 at a time. So it's xy, 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 only 2 of them. They're floats. We're saying that because they can be decimals. And don't normalize them. I'm not actually sure what that does. And then the stride. So between them, how many to skip? So if the stride is 0, that means that after this, just go straight to the next one. But if we could do a stride of 1, so it'd go there, and then we'd go here, because we skipped 1. It's useful if there's like other information in here, like, well, you can't mix types, but if it's like 2.0, and that's just something like arbitrary, like the color, and it's not important for the vertex shader, we can say stride of 1, and then we skip 1, and then go to the next one. Then offset, we don't need an offset because we're starting at the very beginning. Okay, so let's go ahead and bind the buffer now. I need this as in front of all my GLs. I bet, yeah. So TypeScript is being helpful on that. It's saying cannot find name GL. It's true. This is missing a GL. Okay. So line 77. Okay, so I started this. Okay, so this dot GL dot bind buffer. We are going to bind it to our array buffer. Oh, position buffer. I don't actually think we need those. Yeah, we already did this. It's already bound. You don't need to do that. We can move this down here. I think I'd rather have it down there. Oh, whatever, we'll keep it there. Okay, so now we're going to, let's see, this.gl.vertex attribute pointer takes in our program. Did I just call it program? Yeah. Oh, wait, no, so vertex position. Takes in our components, 2. Leave that for future self right now. Takes in our type. So this.gl.float. Takes in our normalize, false. Well, actually, I don't need this. If I wanted to look this stuff up, I'm just going to pulp the docs and docs.gl. Our stride is 0. We're not skipping any. Our offset is 0. We're not skipping any either. Okay, so that's, we're setting up, we're telling GL, how do you read from this buffer data? Here's how you read from it. And then when you read from it, put it into our variable right here. I kind of want to change that to a vec2, but whatever. It's got to be a vec4 eventually. So now this.gl.enable vertex attribute array. That takes in a vertex position, so now it's turned on. So here we're defining it, here we're enabling it. I feel like this should be earlier, but we'll do this here for now. So which program are we going to use? We're going to use the one that goes from here to here. Now we're not doing the uniforms. Okay, so now we need to draw it. So gl.draw arrays. This kicks off the whole program. So basically now GL is going to read from this buffer data and just go through all of them 2 at a time. For each of those, it's going to run this program, which doesn't really do anything. And then for all of the, and when that's done, it's going to run this for each pixel in my frame buffer. And this is going to be based off how this did. So I don't want to use triangle strip though. I just want to use triangles. Triangles, okay. Now actually, I like doing the indexes, but because the WebGL 3 thing, does this inherit from WebGL 1? It does, okay. So, let's see. Well, we'll get into this later, but you can do other things where instead of doing what they did with the triangle strip, now let's see if this works first, and then we'll get into that. So triangles, I'm not done with it. Offset 0. And how many are in there? I have 3 in there. I used GL a bunch of times again. Cannot find name positions. Did you mean position? I don't think so. I think I just meant to name this positions. Cannot find name vertex shader, cannot find name fragment shader, cannot find name GL. So line 68, that's an easy one, let's fix that. Okay, so these two, vertex shader and fragment shader. 34, that's gonna be these 2 types. So this is a property of WebGL2 rendering context. Okay, this is getting really ugly. Boy, okay. Cannot access WebGL2 rendering context of vertex shader because WebGL2 render is a type, but not a namespace. Did you mean to retrieve the type of the property vertex shader in WebGL 2? Yeah, I did. With this? I guess so. I guess that's what I meant. I'm actually not familiar. But I can change it to that if that's what you want to tell me to do. Oh, I made it happy. Okay. Oh gosh. So much. I'm just going to reformat these a little bit because they're so ugly. I feel like I deleted something in that. No. Okay. So, does it draw a triangle? No. Enable vertex attribute index out of range. Index out of range. Let's go look at those. 86. I love source maps, by the way, because it points to my TypeScript despite running JavaScript. Okay, so it is complaining about one of these. Let's see, vertex position. 2 components each. It is a float. Don't know what normalize does, but don't do it. Don't skip. And don't offset. And then later I said, what's the 0? What are all the draw calls I have? I have draw raise, draws raise and direct, instance, draw buffer, draw elements. All right, so draw raise, let's go take a look at it. Takes in a first, which is 0. So the number of indices to be rendered. 3. 1, 2, 3. All right, what doesn't it like? Is it this varying? So I'm gonna see an example shader real quick. Needs to be WebGL 2. In? I guess in. In vec4 vertex position. Or whatever. I'll do the thing you want. Array or attribute position. So that goes into GL position. Okay. So that means I need to change a few places I need to change that over here. Well, I guess just here actually. A position. This is now going to be a position. But that's not actually how we usually do JavaScript here. So I just want to select this word. Okay, so change a position. Okay. Okay, so now we actually have errors. An error occurred compiling the shaders. Actually, just refresh. In. Oh, I don't have the version specified. I need to specify the version I'm going to use. So I'm going to say version 3. An error occurred compiling the shaders. Version directive must occur on the first line of the shader. My bad. So this is a template literal. Unable to initialize the shader program, versions of linked shaders have to match. So I also need that inside of here. I wonder what version it's using if they don't specify. An error occurred compiling the shaders. GL frag color undeclared identifier. Okay. What do you want it to look like? GL_frag color. I mean, that looks great to me. Oh, I need a precision. Probably needs to be on the first line too. Unable to initialize the shader program. Versions of linked shaders have to match. Let's just Google that and see what we see. Well, actually, this text doesn't look like what happened to me. Okay, what versions do I have? Let's see. How do I find the versions? Let's see. Oh my gosh. Template loader holders, please. Doesn't really specify much. I think it was in the constants. Oh my gosh, the word shader. Keep going, keep going. I think I saw the versions in here. What do I MDN? What do I search for? Version 300 ES. No. WebGL 2 shader version. This has to be the first line. No constant blank lines before it. Biggest change of your shaders. So I guess I do want it here. And that can be on the next line. Frag color. Undeclared identifier. Oh, I need to specify an out. What am I doing? Yeah, so I need to be very explicit about what goes out. I can't just have it out. So it's probably always going to be GL frag color. I can name anything I want. So it's going to be vec4 is going to be GL frag color. Okay. Reserve built-in name. Kidding me? So I'm not allowed to use GL frag color. So let's just call it out color, like they suggested. Hey, there's a triangle. Okay. So let's mess around with this for a second. So if I change the second one to the bottom right, I expect it to be the bottom right. None. Oh, that's not the bottom right. Oh, that is the bottom right. This just isn't the top. Oh, I'm getting this wrong. Bottom right is negative on the Y. There we go. And then if I want this to rotate once again, I need this to be a positive one. Not what I expected. Okay, so this is -1, -1. So see if I got the art right. Wait, this is -1, -1? Or do you go to the centers? And we're going to go out 1. And then we're going to go whatever this is. Okay, so let's change one of these and see what happens. Okay, so negative y is down, positive x is left. Okay, so I have this right. Okay, so if I want a triangle, sorry, the squirrel's trying to get to my bird feeder. He's been trying for a whole day now. Oh, is he doing it? He can't quite. Nice try, mister. Maybe one day you'll figure it out. Okay, so he gets so angry at me because of this. He looks at me and barks. Okay, so this is the x, this is the y. So y, x. This is positive 1, this is negative 1. This is positive 1, this is negative 1. Let's do a triangle that looks like this. So I want to go from 0.5, negative 0.5 to 0.50 to, it's a negative 0.5. That's a positive 0.5. I don't have an eraser on the back of this. So this is going to be negative 0.5 again, and then negative 0.5. So let's say this is going to be, let's draw the triangle in red. Let's say this is going to be index 1, 2, 3. Okay. So we're going to change this to negative 0.5, 0.5. We're going to change this to 0.50. We're going to change this to negative 0.5, negative 0.5. And we get that triangle. Yay! So I don't have a square canvas, so it's a little bit stretched out. It's okay. I'm going to call that a day. We're going to go into a Q&A session. So if anyone who's watching, if they have questions, feel free to drop them in the chat and we'll talk about them. During that time, I'm going to set up my bookmarks. I thought I did, but apparently they got erased. So here's day 4, here's day 3. Here's day 2. So this is probably pretty useless. If we get up into the hundreds, if that's even possible, this is going to be a long list of bookmarks. Let's go back up to day 2. And then let's see, day 1. Move, okay. Save. Go down to day 4. So for the next stream, I'm going to leave it to do for myself. Break this out into a triangle function. So we'll just start out with moving triangles around programmatically through our program. So it'd be this dot graphics dot triangle. It would be something like from 1. See, we'll have to figure this out. But I want 3 vertexes, like v1, v2, v3. So we'll have to create a vertex library next, I feel like, before we can get into this. And then eventually I'm going to want a matrix. So I'll have to create a matrix library, which could be a lot of work. I'm tempted to pull one in, but I'd like to create one. This is okay for now. I will want to pull this into an async function to dynamically grab it so I can get my linters and stuff going. Let's put a to-do on that too. Make this a separate file. And this one too. Is my to-do list working? It is. So here are all my to-dos. I have a lot. I love how useless index.js is. What? Oh. It's not listening to the get ignore. Or TypeScript is listening to the comments. TypeScript remove comments. I know there's a TS config for that. Remove comments. Wait. It's not. Okay, let's just try it. So if I go into all my TS configs, I wonder if there's a better way to handle my TS configs. Right now it's like a bunch of them, and they're all relatively the same. So where would I put that? I guess I put it here. Remove comments. True. Just gonna copy it from here to here. Ink. Paste. That is. That's not what I wanted. And paste. Okay. Oh, jeez. Why? Why? Okay, so now let's look at my to-dos. Hey, look at that. It's much clearer now. Or is it? I know it's not. Oh, because I didn't compile all of them. Let's recompile all of them. Guess I go up to folders and run npm run dev. What does that do? Actually, you should look at what that does. Of course, it's doing this weird learner thing. So yeah, it runs dev in all of them. Just nuts. Down to 15. Gosh. Command line. I don't even know. Operation not permitted, unlink. Oh, because I'm currently running it. Let me just kill that. Oh, does that run test in all of them? What does that do? No, it's running dev. Just see what happens. Tools, work for me. Go fast. Wow. I don't know what it's doing. Oh, maybe it's actually just working. Oh yeah, it worked. Okay. So now I have individual ones. So I made 10 to-dos already. So at some point we're gonna have to maybe go through these. I can probably just ignore them for a while though. eventually I'll start seeing them and I'll be like, oh no, it's to do. I wish I did that. Okay. So with that, thank you for watching Corvid Coder. You can always find, if you go to my Patreon, you can always see all the archived videos on YouTube. I don't always do the game utilities one. I've been working on also UI design challenge ones. I'm also thinking about some other projects that I can rotate between. You can always find the code on GitHub Corvid Coder. So this will be pushed up to here in a second. Subscribe to my YouTube video if you enjoyed it. Go ahead and like. Follow me on Twitch if that's where you're watching. Yeah, I think that's all the things. All right, thank you for watching. I'll see you next time. Oh, I stream every Monday through Friday at 1 p.m. Mountain Time. That's worth saying too. All right, cool.